Welcome to your Algebra 2 Lesson 4.3. We're going to be solving quadratic equations of the form x squared plus bx plus c equals 0 by factoring. And so we're going to also be using the zero product property. So we need to go over just a few definitions. Remember, a monomial is an expression that's either a number, a variable, or the product of a number and variable or variables. There's no pluses or minuses. So it might be 2x, 2x, 2xy, 2x squared. Any of those are monomials. Then we get into polynomials once we start adding or subtracting. The simplest type of polynomial is a binomial, such as x plus 4. It's the sum of two monomials. A trinomial, like x squared plus 11x plus 28, is the sum of three monomials. Two binomials frequently multiply together to form trinomials. So if we have x plus 4 times x plus 7, if we FOIL that out and simplify, we get x squared plus 11x plus 28. You can use factoring to write a trinomial as a product of binomials. That's what factoring it is. It's taking an expression and writing it as a product of its factors. So x squared plus 11x plus 28 is equal to x plus 4 times x plus 7. So x squared plus 11x plus 28 is the simplified form. X plus 4 times x plus 7 is the factored form. So in general, let's talk about factoring x squared plus bx plus c. We need to find integers m and n, where x squared plus bx plus c is equal to x plus m times x plus n. Let's FOIL that out so we can kind of see how m and n are related to b and c. So if I FOIL this out, I get x squared plus n times x plus m times x plus m times n. Now, let's go ahead and flip the m and n terms. It doesn't matter, order doesn't matter with adding, it just is going to make it a little easier to remember the important patterns here. Now, I want to combine like terms, so whatever m is, I have mx, and whatever n is, I have nx, so I have m plus n x's. So, simplified form, I'd have x squared plus m plus n times x plus mn. So if you look, our x squared matches up, b matches up with m plus n, and c matches up with m times n. So b is m plus n, and c is m times n. So when you go to factor, what the first thing you're going to do is think of two numbers, m and n, two factors that multiply to equal c. And then you're going to check which of those factor pairs, m plus n, equals b. Some of you can do this in your head. If you're really good at trial and error, guess and check, and you can do it in your head, that's great. But if you struggle with factoring, then this is going to be, we're going to show you a method that should help. An expression that cannot be factored is prime. Alright, so we're going to factor a couple of expressions. Let's look at the first one, x squared minus 9x plus 20. So we want to get in the x plus m times x plus n form. M times n is 20, and m plus n needs to equal negative 9. So one thing you can do is make a table, and you would fill in the first row first, and then come through and fill in the second row second. So first thing you would do is think of all factor pairs that multiply to equal 20. So start with 1, so 1 and 20, then do both the opposites, because negative times negative is positive. So negative 1, negative 20. All right, so does 2 work? Yeah, 2 and 10, and then you would do negative 2, negative 10. 3, nope, 3 doesn't work, and so you'd have 4 and 5, and then negative 4, negative 5. The next number up is 5, and you get 5 and 4, which is the same pair we already have here, so we know we can stop. Now we look at the sums. 1 plus 20 is 21, negative 1 plus negative 20 is negative 21, 2 plus 10 is 12, negative 2 plus negative 10 is negative 12, 4 plus 5 is positive 9, we need negative 9, negative 4 plus negative 5 does give us negative 9, so this is our m and n pair. So we're going to have x squared minus 9x plus 20 equals x minus 4 times x minus 5. Alright, so we want to do the same thing with x squared plus 3x minus 12, so we need m and n to equal negative 12 and m plus n to equal 3. So we write all the factor pairs for negative 12, which means we need one negative and one positive. So negative 12, or negative 1, positive 12, and then one negative 12. Negative 2, positive 6, positive 2, negative 6, negative 3, positive 4, 3, negative 4. And then we look at the sums, and we're looking for a sum of 3. So let's see. -1 plus 12 is 11. 1 plus -12 is -11. -2 plus 6 is 4. 2 plus -6 is -4. -3 plus 4 is 1. 3 plus -4 is -1. None of those are 3. So I know I have a prime polynomial because x squared plus 3x minus 12 cannot be factored, so we just say it's prime. So that would be your answer for this problem, is prime. Okay, there are special factoring patterns that you need to know. You've probably seen all 3 of these in Algebra 1. Definitely the difference of 2 squares. I call difference of 2 squares dots. Always look for dots just from getting started. Notice here we don't have a trinomial. We just have a binomial. And so if you just have 2 terms today, the big thing you want to look for is can you see dots? Okay, is it a difference of 2 squares? So a squared minus b squared factors out to be a plus b times a minus b. So if you have something like x squared minus 4, 4 is 2 squared, so it factors to be x plus 2 times x minus 2. The other 2 perfect square trinomial factoring patterns, those are just a quick way to factor special kinds of trinomials. You could do the m and n way. That works just fine. But let's look and see that this can be done really quickly. So if you have a trinomial that fits the pattern a squared plus 2ab plus b squared, it can be factored very quickly as square root of the first term, so a, plus square root of the second term, so b, quantity squared. So if I have something like x squared plus 6x plus 9, if I notice that 9 is a perfect square, okay, that's 3 squared, I can check the middle term to see if it equals 2 times first square root times second square root. So 2 times x times 3, yep, that's 6x. And so it can be factored very quickly as x plus 3 squared. It works also if you have a minus here in front of the middle term. It's just you're going to have a minus in your factored form. You need to memorize these, and you need to take note that the sum of 2 squares is not on here. That's because a squared plus b squared is prime, always. You cannot factor it. All right, we want to factor x squared minus 49. Let's see, 49 does equal 7 squared, so we've confirmed that it's a difference of 2 squares. We haven't factored anything yet. We don't have anything we don't have parentheses. We don't have 2 things multiplied together to equal our expression. So we've confirmed that it fits the pattern. Now we've got to apply it. So it's going to be x plus 7 times x minus 7. D squared plus 12d plus 36. Let's see, 36 is 6 squared, so we do have a perfect squared trinomial because we can write it as d squared plus 2 times d times 6 plus 6 squared. Again, we haven't factored it yet. We've just shown it fits the pattern. The factored form is d plus 6 quantity squared. We've got z squared minus 26z plus 169. 169 is 13 squared. Negative 26z can be written as negative 2 times z times 13, so we do have another perfect square trinomial. And because it has a minus before the middle term, we can write it as z minus 13 quantity squared. All right, zero product property. We've been practicing factoring. Now we're going to actually solve some equations using factoring. If the product of 2 expressions is 0, then one or both of the expressions equals 0. In other words, if a and b are expressions and a times b equals 0, then either a equals 0, because 0 times b, no matter what b is going to equal 0, or b equals 0. A could be anything else, b is 0, and you're going to end up with 0. So if we have x plus 5 times x plus 2 equaling 0, then x plus 5 equals 0, which will give us a solution of x equals negative 5, or x plus 2 equals 0, which gives us a different solution of x equals negative 2. So we have 2 solutions. Now, one thing worth noting is that in order to be able to do this process here, you have to have the quadratic equal to 0. So if it equals anything else, you have to move that number over with the rest of the quadratic, then factor, and then solve. One thing you need to know is that the solutions of a quadratic equation are also called the roots of the equation. So when you're asked what are the roots of the equation x squared minus 5x minus 36 equals 0, you're just being asked to solve. Okay, so we want to write the original equation, and then we want to factor it. If you need to make the little table, you can. Let's see. Numbers that multiply to be negative 36 and add to be negative 5 would be negative 9, positive 4. So x minus 9 times x plus 4 equals 0. We set each factor equal to 0, so x minus 9 equals 0, or x plus 4 equals 0. So we get x equals 9. or x equals -4, so that would mean the answer is C. You learned that the x-intercepts of the graph of y equals x minus p times x minus q are p0 and q0. Had those on there backwards. Let me fix it. Don't want y'all learning something incorrectly just because I was silly. Okay, so because the function's value is 0 when x equals p and x equals q, all right, so here's the x value. So when x equals p, the function equals 0. When x equals q, the function is 0. Then the numbers p and q are called the zeros of the function. Find the zeros of the function by rewriting the function in intercept form. So we have y equals x squared minus x minus 12, and y equals x squared plus 12x plus 36. So let's look at our solution. We're going to write the original equation. Okay, we're going to factor. So let's see, we need numbers that multiply to be -12 and add to be -1, because there's an understood 1 there. So how about -4 and +3? So x plus 3 times x minus 4. We set each one of those equal to 0. X plus 3 equals 0. It's going to give us x equals -3. And x minus 4 equals 0. It's going to give us +4. So the zeros of the function are -3 and +4. Let's look at the solution for B. All right, we're going to factor. When we factor numbers that multiply to be 36 and add to be 12, we're going to be 6 and 6. If we set x plus 6 equal to 0, we get -6. We set this x plus 6 equal to 0, we get -6. So the zero of the function is -6. Because two separate factors yield -6, it is considered a double zero or a double root. Sometimes you'll hear it called that. Okay, guys. That is it for your examples. Please do the problems to try on your own. If you can't even get started on them, remember that means you need to go back and review the video, look back through your notes, or come in and get some help. Okay? All right, guys, thank you for taking such good notes. I will see you in class. I hope you have a great day.